This is section 6.5, percents of increase and decrease, and today we'll be talking about a percent of change. So a percent of change is the percent a quantity changes from the original amount. So we've got a percent increase, and for a percent increase, the new amount will be larger than what the original amount was, so it goes up, as you can see. And on a percent decrease, the new amount will be smaller than the original amount, so it will go down. So percents increase and decrease. For example, we could have a tax rate that goes up, and maybe we have to pay a larger amount. We've got, when we go to the store and buy something, the new amount after tax is going to be larger than what the original amount was. Or maybe it's been discounted. Maybe the new amount is going to be lower than what the original amount is if it's a discount. So what we need to remember for percents of change is we actually have this nice little equation. A percent of change is simply the difference divided by the original amount. The difference divided by the original amount. That, when you do top divided by bottom, is going to give you a decimal, and then we just have to write it as a percent. So let's go ahead and practice that. So it says find the percent of change. In example A, 12 increases to 20. So using the little key up here, I know that I'm supposed to take the difference. Well, one thing you need to remember about the difference is that difference means to subtract. Okay, so I need to subtract the two numbers. Always do the bigger number first. 20 minus 12 is 8. So 8 becomes the top part of our fraction. Then it says the original amount. Right? The original amount is always going to be the first number that they give you. So that would be, in this case, 12. So when it says find the percent of change, we subtract 20 and 12 to get 8, and we put it over 12, and that gives us a fraction. But we want the percent. So we convert this percent, or this fraction, into a decimal by doing top divided by bottom, and then to a percent. So if you do 8 divided by 12, you'll get 0.6 repeating. So that's actually 2/3. And then when you move the decimal 2 spots to the left, we'll get 66.6 repeating, or 66 2/3%. Now, if it says round to the nearest tenth of a percent or round to the nearest percent, pay attention to those, because if it's wanting you to round, it won't take the correct answer unless you've rounded it. So let's just round to the nearest percent in this case. If I round to the nearest percent, it is much closer to 67% than what it would be to 66%. So we'll just say for right now, we'll round to the nearest percent if we have a decimal. In example B, we do the same exact thing. This is a percent decrease instead of an increase, but we still do the same thing. We take the difference, so 50 minus 25 is 25. So take the difference, put it over the original, which is always the first number, and then turn that into a percent. So 25 over 50 is, you might recognize that as 1/2, which is 0.5. It's okay, you can just do top divided by bottom. And then 1.5 would be the same as 50%. So that's a 50% decrease. So that's how you find percents of change. Okay, so let's look at a couple story problems so we can see how we can apply this. This says the table shows the number of hours you spent online last weekend. What is the percent of change in your online time from Saturday to Sunday? So remember, to do this, we're going to find the percent of change, which is the difference over the original amount, there we go. So we subtract 4.5 minus 2. So 4.5 minus 2 is going to give us 2.5. Then we put it over the original. Well, Saturday was the first day, so our original amount was 2. And then we turn this into a percent, turn this fraction into a percent. How do we do that? We do top divided by bottom, just how you turn normal fractions into decimals first. And 2.5 divided by 2 is 1.25. And then we turn that decimal into a percent by moving the decimal over twice. So 125%. Our hours increased by 125%, so they went up more than double. Okay, so let me recap again. We took the difference, we subtracted the 2, and we got 2.5. We put it over the original, which was 2, and then we turned that into a decimal by doing top divided by bottom. That gave us 1.25, and then we converted it into a percent. Okay, on the next example, it says the bar graph shows a softball player's home run totals. What is the percent of change from 2012 to 2013? So those would be these two seasons right here. And we went from 28, that was the 2012 total, and we actually went down to 20 home runs in 2013. So this is going to be a percent decrease. So the first thing I do is I take the difference between those, which means to subtract difference. And 28 minus 20 is going to be 8. Always take the bigger number first so we get a positive number there. The second thing I do is I put it over the original. The original number was 28. That was our 2012 number. And that gives me a fraction that I turn into a decimal and then into a percent. So 8 divided by 28 is, I'm going to have to round here, 0.28, and then that 7 rounds the 5 up to a 6. So try that in your calculator so you can see what I'm looking at. We're going to have to round this. And let's go ahead and round this to the nearest tenth of a percent. The tenth of a percent means after I've moved the decimal twice, is it 28.6 or 28.5 or 28.6? And it's gonna be 28.6% because the 7 would round the 5 up to a 6. So 28.6% change. Okay, so we'll try a couple on your own. This first one says 10 inches is going to change to 25 inches. So if you need to rewind, go ahead and do that, but I want you to think, how would I do this? How would I find the percent of change? Remember that it's difference over the original. That's going to give you the fraction, and then you turn it into a percent. So go ahead, pause if you need to, try this one on your own, and then I'll come back and give you the answer. Okay, so if you're ready for the answer then, the way you would do this, again, finding the difference, is you're going to subtract the two numbers, starting with the big one first. 25 minus 10 is 15. And then you put it over the original. The original number was 10. Okay, so we have 15 tenths. So we do top divided by bottom. Top divided by bottom is going to give you 1.5 as a decimal. So we've gone from fraction to decimal. And then to percent, we're just going to simply move the decimal over 2 spots to the right. And that's going to give us 150%. So that was a 150% increase. So if you think about this, going from 10 to 25, if you went up another 10, that would be a 100% increase because you're doubling it. You're taking all of 10, 100% of it, and you're adding it on to it. So that would be a 100% increase, and that would be giving us 20. So if I take another half of that, that would be 50%. That would give us 25. So that's 100% of 10 plus 50% of 10, and that's why we call it a 150% increase. All right, here's two more. Let's see if you can do these on your own as well. Go ahead and pause, and when you're ready, come back, and I will show you the answers to them. Okay, so for example B, 57 people to 65 people. Again, we take the difference, 65 minus 57. And that's going to be 8. And we put it over the original number, which is always the first one. So 8 over 57. At this point, guys, it's just an FDP conversion, going from fraction to decimal. So 8 divided by 57 is, if I round here, it's going to be 0.14, and then that 3 is not enough to bump the 0 up, so that would be 0.140. And then I'm going to slide the decimal over 2 spots, and that's going to make this 14%. And then for example C, again, we subtract the two numbers. 115 minus 10 is 105. and then we put it over the original number, which is 115. So 105 divided by 115 is 0.913 is what it would round to, and that's going to give us 91.3%. And that's a big change, and this is a big change. So go from $115 to $10 means you're spending 91.3% of your money. Okay, this next problem is a homework problem from section 6.5. Number 26 says, suppose the length and width of the sandbox are doubled. Find the percent change in the perimeter, and then find the percent change in the area. So let's do the perimeter first. The perimeter as of right now, the original perimeter, I might add, so original. The original perimeter is 10 plus 10, which is 20, plus 6 and 6, which is 12, and 20 plus 12 is 32. Remember, perimeter is the distance around a shape. So that's the original perimeter. But if I double everything, it says if it is doubled, then this would now be 20, and this would now be 12. So my new perimeter would be 20 plus 20, which is 40, 12 and 12, which is 24, and 40 and 24 is 64. So you can see if you double the perimeter, or if you double the side lengths, you'll actually just double the perimeter. So this is for perimeter, I might add. So we'll do one separately for area. So if I want to find the percent of change here, this is obviously an increase. I'm going to subtract the 2, and I always do the bigger one first. So 64 minus 32 is 32, and I put it over the original. Well, the original is 32. So 32 divided by 32 is 1, and if you move the decimal, that's going to give you 100%, which means you have doubled it. If it's a 100% increase, then you have doubled, because it was 32, you added another 32 to it, and now it's 64. So 100% increase means it has been doubled. Okay, so for the area, let's find the original. Remember, for a rectangle, you do length times width. So the original area would have been 6 times 10, which is 60. But if you double it to 20 and 12, then the new area would be 20 times 12, which is 240. So this does not just double it. It actually, 6 times 4 is 24. It actually quadruples it. Okay, so it did not have the same effect because we were multiplying this time. So to find the percent of change, we do the same thing. We're going to subtract these two. 240 minus 60 is 180. Put it over the original. So 180 and the original would have been 60. So 180 over 60. And then we're going to turn that into a decimal. And that is 3. And then we're going to convert that into a percent by moving the decimal over twice, and that's going to give us 300%. So this is 300% increase from using the area instead of using the perimeter. So make sure you get this work copied down on your work paper, and that's number 26 for you. And the final thing we're going to talk about today is percent error. Percent error is very much like percent change with one small difference. A percent error is the percent that an estimated quantity differs from the actual amount, or I guess you could say the correct amount. So here we have a formula. And this is the equation for percent error. Instead of being difference over original, you can see the only change is that it's difference over the actual. So the original number was always the first one. The actual one may not be the first one. You have to read to pay attention to it. But other than that, everything else is the exact same. This one says you estimate the length of your classroom is 16 feet. The actual length is 21 feet. Find the percent error. So we start off by finding the difference, just like we did before. The difference would be 21 minus 16, which is 5. Okay, so you're off by 5 feet. That's the difference. Then, instead of putting it over 16, which is the original number, it says the actual length is 21. That's the number we want to put it over. So you have to pay attention and make sure you read. Other than that, everything else is the exact same. We turn that fraction 5 over 21 into a decimal. 5 divided by 21 is 0.23, and that would round to an 8. So then I move the decimal over twice, and that gives me 23.8%. That's how much I was off by when I originally thought the classroom was 16 feet in length. It's actually 21 feet, so I was off by 23.8%. That's how you find percent error. It's difference over the actual amount, not the original amount, because there is no original amount. There's a wrong answer and there's a right answer, so always put it over the right answer. All right, so let's look at a couple of other homework questions. Number 19 says you estimated that 200 people attend a school concert. The actual attendance was 240. Find the percent error to the nearest tenth of a percent. Now again, tenth of a percent means that we're actually going to use we're going to round to 3 decimal places. And then when we move it over twice to change it to percent, we'll only have 1 left, that 10th place. So the first thing we do is we're going to subtract these two numbers like we've been doing. 240 was the actual amount. Always do the biggest one minus the smallest one. You predicted there was 200, and that's a change of 40. So you were off by 40. Now you put it over the actual amount. Well, if you read, it says the actual attendance was the 240. So don't put it over 200, put it over 240. And then that's going to give us a fraction that we can write as a decimal. 40 divided by 240 is 0.16 repeating. So when I move this decimal over twice, that's 16.6 repeating. But it says round to the nearest tenth of a percent. So that's actually 16.6. 6 is closest to 16.7. That 6 would bump the other 6 up to a 7. So now we have 16.7% is our error. That's how much we were off by. So that would go over there. And then it says, what other estimate would give you the same percent error? Explain your reasoning. Well, when we guess, we said there would be 200 people. We were off by 40. But there's another guess that would make you off by 40, right? So if we want to keep this fraction the same, then our percent would stay the same. Think about it. What other guess, other than 200, would have put us off by 40 people? Like we would have been wrong by 40. Well, instead of being short 40 people, we could have overestimated by 40 people. We could have guessed there would be 280. And if there was 280 people, you would do 280 minus 240, and you'd get that same fraction of 40 over the correct amount, which is 240, which is going to give you that same percent. So the other estimate says to get the same percent error, the amount of error needs to be that 16.7%, so it needs to be the same. Because your estimate was 40 people below the actual attendance, an estimate of 40 people above the actual attendance will give you the same percent error. Therefore, the estimate that gives you the same percent error is, as we said, 280 people. You'd still be off by the same exact amount, so you get that same percent error, just in the other direction. Now, for number 24, it says, explain why a change from 20 to 40 is a 100% increase, but a change from 40 to 20 is a 50% decrease, not a 100% decrease. So the reasoning for that, and I can see how this can be very confusing, it's all about what the original number is. So in the first example, the original number is 20. So if I go from 20 to 40, I am doubling it, right? So not only did I start with 20, but I'm adding another 20 to it, which is 100% of 20. 100% of 20 is 20. So I'm adding 100% onto it. So that's going to double it. But in this next one, it says 40 to 20. Well, the original number is now 40. It's not 20 anymore. So if I was going to do a 100% decrease, then I would need to subtract by 40. That would be the opposite of 100% increase. But I'm not subtracting by 40. I'm subtracting by 20, which is half of 40. So it all depends on what that original number is. That's how you get that percent. So increasing from 20 to 40 is the same as increasing 20 by 20. So it's a 100% increase. Decreasing 40 to 20 is the same as decreasing 40 by 1/2 of 40, which is 20, which is a 50% decrease. Okay, let's look at a few more homework problems. We're actually doing quite a few homework problems together in this lesson. Number 28 is a percent change one. This is not a percent error. It says in June, a runner ran a mile of 7:45. In September, they lowered it to 5:51. Is the percent of change in time an increase or a decrease? And obviously it's a decrease, right? We're lowering our time, so that would be a decrease. And then it wants to know what the percent is to nearest hundredth of a percent, which is 2 decimal places after you move it over twice to make it a percent, which means I actually need 4 decimal places. So the first thing I want to do is I want to convert these times into seconds instead of minutes and seconds. I can't have them as minutes and seconds. I have to have them as just seconds. So 7 minutes, you have to think, okay, well, how many seconds are there in a minute? There's 60 of them. So if you times that by 7, that's going to give you 420 seconds plus the 45 extra ones. So that means your original time in seconds was 465 seconds. That's converting the minutes to seconds. Now, for your new time was 5 minutes. So 5 minutes times 60 seconds per minute is 300. So that's how many seconds are in 5 minutes, 300 seconds. Plus 51 extra seconds gives you 351 seconds. So you lowered your time by quite a few seconds. Now we can find the percentage change. Take the bigger number minus the smaller number, 465 minus 351. And you need to be using a calculator for all this. Make sure you've got one handy. That's going to give you 114, and then you put it over the original. Well, remember the first time they gave you was your original, and that was 465 seconds. You have to have everything converted to the same units, so seconds. Then we're going to turn that fraction into a decimal. So taking 114 and dividing it by 465 gives you a long decimal. And I need to round it to 4 decimal places, 4 of them. So that was going to be, if you do this in your calculator, you get 0.245, and then that 1 is going to bump, because it's 1/6, that 1 is actually going to bump up to a 2. The reason that we need 4 decimal places is because it says round to the nearest hundredth of a percent. So once I move it over twice, I've got 2 decimal places left. And that's what hundredth of a percent means. So 24.52%. It means I need a hundredths place after I move it over twice already. So that's 24.52% decrease for number 28. Now, our next 2 problems actually lead into what our next section is going to be over, which is over discounts and markups. So let's figure out how to do this. This is not a percent change because they've already told us what the percents are for both of these. So we already know what the percent change is. We just have to find out what the new amount is going to be. So it says 8 meters increased by 25%. How many meters is that? So if it increases by 25%, the first thing we need to find is what 25% of the original is of 8. So we need to know what is, this sounds like a percentence, what is 25% of 8? And it's exactly what you would do. That's why we did that percentences section. We know the word of means to multiply. We know that 25% is 0.25, and 0.25 times 8 is 2. And then it said it increased by that much. So if 8 increased by 2, that gives us 10 meters. Okay, so that would be an example of a markup like we'll talk about in our next section. And this next one, exercise 6, is an example of a discount. So let's say you're buying something for $50. I know it says 50 points. And it's on 26% off. So how would I find out what that new amount is going to be? Well, we're going to do the exact same thing. We need to know what is 26% of 50. So what is 26% of 50? So we replace of with the times, change 26% to 0.26, and we do 0.26 times 50. 0.26 times 50 gives us 13. Now, because it says it was decreased by that much, it was decreased by 13, we're going to subtract 13 instead of adding 2 like we did in the last one. So we are going to subtract 13. So 50 minus 13 gives us 37. So that is our new amount, is 37 points. So those are the only 2 problems that are like this. These are different, right? They're different from the rest of them. They're kind of talking about what we've been doing. They're percent going down, percent going up. We just have to find that new amount, which is what makes them different. That's going to be the next section. So I wanted to do these 2 with you just to show you what we'll be doing next section.